ABCD is a square and BDEF is a rhombus with AE and F collinear. So they're in a straight line, AE and F, and we need to find angle ADE. So this is angle ADE, and so we can start with marking all the right angles and also the 45 degrees. So you see BD is the diagonal. So we have several 45-degree angles, and this entire angle is 45 degree. So I can write angle BDA is equal to 45 degrees. Okay, as well as the other ones, but because the angle we need to find out is included within the 45 degrees angle, so it's definitely less than 45 degrees. So the next step is the rhombus. If we could, the opposite sides are parallel and they're equal, so if we do the parallel bit, so this is parallel, and because AEF is collinear, so it would be parallel too. So BD is parallel to AF, and therefore you would get alternate angles. Angle BDA is equal to, or rather no, I wrote the wrong angle, sorry. Angle DBA is equal to angle BAF. So this is the angle. So BA is a transversal, so angle BAF is 45 degrees. Therefore, angle DAF or angle DAE is equal to 90 plus 45, that is 135 degrees. So here we are talking of this angle. So this is 90 plus 45, so this entire angle becomes 135 degrees. Okay, so then what I thought we should do is, we can assume the side lengths, because there are so many equal sides, and it would be interesting to assume the side lengths. So suppose the length of the square, the side of the square is equal to x. Suppose the square, I don't know where to write, so I'm just going to write somewhere. So suppose the side length of the square equals x. So the CD is equal to BC, that's x, AD is x, and so is AB, that would be x as well. So we're more interested in AD being x, and we have this 190 degrees angle. So now what about the sides of the rhombus? Now BD being the diagonal, so BD I can write BD by applying Pythagoras theorem is equal to, I can write it as square root of x squared plus x squared. that is equal to 2x squared, square root of 2 and x. So this side is root 2x, and therefore sides of the rhombus would be root 2 times x, and therefore DE would be root 2 times x. So this is root 2 times x. So we need to use trigonometry to find the angle ADE. I couldn't find it out in any other way. You can have a go and use any other method to try and work out what the angle will be. I thought we could use trigonometry, and it's quite simple that way, because we have in triangle DAE. So once again I write all over the screen, so I am going to do that. So I can write in triangle DAE. So once again I will note down what we have. That is angle DAE equals 135 degrees, and DA equals x, and DE equals root 2x. So we need to find DEA, and we assume angle DEA is equal to theta. Suppose, okay, suppose. So we are assuming that angle DEA is equal to theta. So now I am going to apply the sine rule. So I can write sine theta out of x is equal to sine of 135 degree over root 2x. So you see, though there is a variable x, so it gets cancelled out. So very neatly. So then what we have is sine theta, sine 135 degrees we can find out, because sine of 135 degrees can be written as sine of 180 degrees minus 45 degrees. That is equal to sine of 45 degrees, and we know sine 45 degrees is root 2 over 2. So I can write sine theta equals root 2 over 2, and this root 2, so 2 root 2. So that is equal to half. So therefore theta is sine inverse of half. So theta sine inverse of half, and so theta equals 30 degrees. So we have angle DEA is 30 degrees. Now this is very important, I thought, to be able to find angle DEA, because then we know the two angles in this triangle, DAE to DA or ADE, and we can find angle ADE. Very easy. So angle ADE is equal to, we do 180 degrees minus 135 degrees plus 30 degrees. So that is equal to 180 degrees minus 165 degrees. And that is equal to 15 degrees. And the answer is 15 degrees.